All right, hello everybody. I just want to make a short video today to walk you through the basics of homework number 2, which is due on Friday in 5 days if you're watching this video on the day that I make it. Hopefully I'll get it up that soon, but it's due on Friday the 17th at the end of this week. This is a pretty straightforward exercise. Basically the idea is to help get you used to entering commands in R and having R do things for you, either graphically or analytically. And so it's a bit of busy work, but it's designed to kind of ingrain these, procedures in your head, basically, so you feel more comfortable using the software. So the only real issue, well, there's maybe a couple of real issues with this homework that people have had in the past, but the main thing I've had people have difficulty with in the past is just figuring out exactly what the specific tasks are, because there's a lot of them. So I'll walk you through them in sort of outline form, and hopefully if you have any questions you can refer to the video first, but if you still have questions after watching this you can ask me by email or directly. But the first task, which is task number 0 because it doesn't really count for anything, is to download the data files for each speaker from this internet directory. So we're using the VOT data that you collected last week. I combined it into one big data file, which you can find in the datasets directory here. So it's the 2021 class VOT measures for homework number 2. If you click on that, you see all of the speakers in the class. Well, a few people sent in incomplete data, so unfortunately I'm leaving you off of this data set for now because I need to have sort of uniform data set for everybody. But basically what you get is the speaker of a word and what they measured their VOT to be. It tells you what the word is, what stop is at the beginning of the word, what vowel is in the middle of the word, and then which repetition of that word they are producing for this VOT measure. So everybody has 3 repetitions of every single word, and then there's a lot of different speakers in the database, right? Okay, so I just want you to kind of like dig into the database and get to know it using R commands. So the first 3 tasks involve a little bit of busy work, but it's fairly straightforward. So for this one, I want you to pick 3 speakers from the VOT data frame that we just looked at here. And for each speaker, calculate and report the following statistics for their VOT measurements: the mean, the 5-number summary. If you don't know what that is, look through the notes. The range, the interquartile range, the variance, and the standard deviation. So again, if any of this doesn't make sense to you, it's in the notes. Go review them. I just want you to report these sort of ideally in the form of like some sort of table. You can draw it up in Word or Excel or what have you, whatever works for you, as long as it's easy for me to process. Before I get further into this homework, I will just point out that I want you to submit to me your R console that you use to actually execute all these tasks in the homework. So as you can see up here, I was just doing some examples, but I've shown you in another video how to save this R console. The commands that you use in your R session, you just save as, and then it goes to wherever you need it to go in your hard drive. And I want you to do this starting from the very beginning of all these tasks so I can see exactly what you did, because if something gets messed up, then it'll be far easier for me to explain how to fix it if I can see the commands you're using and know where things went wrong. Yeah, so that being said, even though I want you to save and submit that R console for me, and in the R console you'll be doing things like figuring out what the mean of some data set is, or the standard deviation, what have you. I don't want you to just like report these numbers by giving me the R console. I also want you to kind of package it up in a nice format, and then send me that nicely formatted package so that I can just interpret your data that way rather than digging through the R console commands to kind of reconstruct it. The R console is there so I know what happened when things went wrong. If things go right and you get the right information I'm asking for, please present that in a nice digestible format. That's part of what we do as scientists, is present things in a way that other people can understand, right? Otherwise it's kind of useless, our attempts to communicate the value of our work to other people. So let's also get some practice at doing that. Tasks number 4 through 7, on top of calculating or reporting these measures for 3 different speakers from the VOT data frame, in tasks 4 through 7, what I want you to do is consider the data from all of the speakers in the data frame combined. That is everybody, not just the 3 you chose from tasks 1 through 3. So for this set of data, report the 6 statistics up above for each of the 3 places of articulation separately. So in other words, using the entire data set, I want you to consider all the bilabial stops. And if you haven't taken Link 201, number one, you should take Intro Linguistics. It's a good class and you will remember it forever. But one of the things you will learn in that class is that P is a bilabial stop, which means you use 2 lips to create it. T is an alveolar stop, which means you produce it at the alveolar ridge using the tip of your tongue behind your teeth. And K is a velar stop. So basically what I'm saying here in this one is report the statistics here for the bilabial stops, for the alveolar stops, and for the velar stops. That's 3 separate tasks. And then also for all of the tokens in the VOT data frame combined. So for all speakers, all stops, just throw it all in there and then tell me what these statistics are for that data set. So again, 3 different places of articulation, bilabial, alveolar, and velar, and then everything. Those are tasks 4 through 7. And like I say here, take all the data you've collected in tasks 1 through 7 and present it in the form of a table, i.e. don't just send me this data in the form of the outputs of your R commands, because that's just a total pain in the butt. You have to do that part of the pain in the butt process. I will do the sort of double checking of everything at the other end just to make sure you got this stuff right. Okay, so hopefully that makes sense. Tasks 8 through 11, we start to work on some graphical presentation of the data. So for this, the first 3 tasks, again, you're going to be splitting the data up into different places of articulation, bilabial, alveolar, and velar. So for each place of articulation in the VOT data frame, generate a histogram. And then, like you did for this batch of tasks, in addition to doing or making a histogram for each place of articulation, also plot a histogram for all of the data in the data frame combined, right? So go through, just make one for P, make one for T, make one for K, and then make one for everything. PT and K, all the speakers are just in one data frame. Make a histogram for that. There's a few kind of deep thought questions here for everybody. And this is just to kind of get us thinking about like distributions in general. So do the histograms you generated look like they form normal distributions? If they don't, how are they different from something normal? Are the distributions skewed in one direction or another? Just tell me basically a little bit about the shape of these distributions that you can see in the histograms. Yeah, and so I've got this note here about package this all up into a nice little short write-up. It can be very short. It's fine if just have 1-sentence answers for these various questions. I just want to make sure you're thinking about these things and presenting it in a way that's easy to read and understand. And you can use any file format you like, whatever works for you, as long as I can read it. It doesn't matter if it's Word or PDF or whatever. I can even use those funky open source softwares or open source softwares. Is that a pluralizable noun? I guess so. Or the Mac, Pages, whatnot, Numbers sort of software packages if you prefer to use those. I'm not going to dwell on that too long. Whatever works works for that purpose. For tasks 12 through 13, I also want you guys to go to the next sort of graphical step and start creating box plots. So for this, what I want you to do is to pick 2 speakers from the database. And for each speaker, create a box plot of their VOT data that shows the VOT for each place of articulation with all 3 places of articulation on the same graph. And for whatever reason, people have had a hard time understanding these instructions in the past. So I'm going to give you kind of an example that's related, but not exactly the same thing. So this is from when I walked you through the very basics of R in that short commands video that hopefully you've seen by now. And this is showing you the distributions or the box plots for P's in the different collections that Svetlana and I made way back when. And this is the box plot for Svetlana's data, and this is the box plot for my data. What I'm asking you to do with this new data set is to say, well, have the bilabial VOT over here, have the alveolar VOT over here, and then you have another sort of column for the velar VOT over here. I'm not going to show you exactly what that looks like, and I'm not going to tell you exactly how to do that because I want you to figure that out as part of this exercise, but that's what it should look like. 3 places of articulation side by side in your box plot. Yeah, and then also do something similar for tasks 14 through 15, but in this case, you're not looking at different places of articulation. In this case, you're looking at the different repetitions of the tokens. So remember, we read each word 3 times. So instead of having bilabial, alveolar, velar, in that next box plot, what I want you to do is repetition 1, repetition 2, repetition 3, right? And you're going to make one combined box plot for one particular speaker you like, and then another combined box plot of the repetitions for another speaker you like. For both of these tasks, you're picking 2 speakers. They don't need to be the same. Well, yeah, actually I said these same 2 speakers, so I'll stick with that. So pick 2 speakers from the database. And one of the reasons I kind of have you pick 2 is because I think if I just had you pick 1, you might very well pick yourself, and then that gets kind of boring. So pick somebody else as well as yourself, or just pick 2 different people altogether. I don't care as long as they're different from each other. And then create these box plots for them. Yeah, and these are not, well, this particular box plot is labeled and gussied up. So you can label and gussy up your own box plot appropriately and save them into graphics files and then submit them to the Dropbox. Part of the exercise, again, is just learning how to save these things into graphics files on your computer. It's just a practical thing that way that will be useful for you if you ever have to create graphics for your own reports in the future when you're moving beyond just doing this for class. Ling 660 students, in addition to just learning the practical basics of this, also should think a little bit about what's going on here by answering a series of deep thought questions. So does one place of articulation or another have a consistently higher or lower VOT than the others? Are there speakers who have a consistently higher or lower VOT than others? What do you think based on how you look at the data? Does VOT change between the repetitions of words? What do you think might be a good way of quantifying the differences in VOT between speakers or groups of sounds? How could you tell if the differences are consistent or not? And like I said, these are just thinking questions, kind of discussion questions, if you may. So you don't have to have like the right perfect answer for this. I just want you to go through the process of thinking about this in a serious way. Like, how would I figure out if there's a consistent difference between like speakers or places of articulation or not? So you don't have to run any tests to do this, or even cite any tests if you don't know any. Just tell me what you think. How can you conceptualize or imagine the process of quantifying consistent differences between distinct distributions? If you're in the Ling 660 class, I want you to do that. If you're in Ling 560, you don't have to. You can if you want. That's up to you. But either way, once you're done with all of these various tasks, I want you to save that R console so that I can see all the commands you used, and then save your tables and your little write-up and your figures, all that. Send that all to me through the Dropbox on D2L, just so I can see what you accomplished and know exactly what steps you took to accomplish those tasks. That's your homework for this Friday. And if you have any questions, you can submit those questions to me through swinters@ucalgary.ca. And like I said, hopefully that's all clear. I've tried to make it as obvious as possible, but if it still is uncertain or unclear to you what to do, get in touch with me as soon as possible. Okay, good luck, have fun. I'll see you again for homework number 3.